Hello, it's Keith from Kinvert, and we're going to be doing another quadratic equation that will result in complex roots. This time, let's look at what's going to happen if b equals 0, right? So let's make an equation here. We're going to do 4x squared, and how about plus 25 equals 0. So we've already got it in standard form of ax squared plus bx plus c equals 0. And for a quadratic equation, as long as a is not equal to 0, everything's good. So in this case, we have an a equals 4, b is 0 because there's no bx term in here, and c is 25. Time to take a look at the quadratic equation, and that is negative b plus or minus the square root of b squared minus 4ac, and this is divided by 2a. But what are we supposed to do? There's no b, so how are we supposed to do the equation? Well, b is a variable, right? We're just going to toss in the value of it. In this case, it's 0. Let's begin with negative 0 plus or minus the square root of 0 squared minus 4a is 4 and c is 25. So we'll do that and divide that by 2a. Again, a is 4. So what do we have? 0 minus 0 squared. All right, so 4 times 4 is 16 times 25. 16 times 25. 16 times 25 is 400. We have the square root of negative 400 divided by 8. Well, there is no square root of negative 400. So we are going to do the square root of 400 times I divided by 8. Notice the I is outside of the square root. What is the square root of 400? I'm not even sure. Hopefully it's a good clean number. It is. I should have known that. It's 20. So now we have 20I divided by 8. Oop, and this is a party foul here. I forgot this plus or minus for each of these. So we've got the plus or minus for each of these. 20 divided by 8. Thought so. We end up with, should I do it in fractional form? I'll do it in fractional form. So what do we have? We have 10 divided by 4. And 5 divided by 2. So the final answer for the fully worked out number here, instead of going with decimals, is plus or minus 5 halves I. And so this would be x equals negative 5 halves I and 5 halves I. And 5 halves is equal to 2.5. So this is basically equivalent to saying x equals negative 2.5 I and 2.5 I. In this case, the real part is 0, and the imaginary part is 5 halves. So we have an equation without a b term. There's no bx here, and so we put 0 in the place of b, that's the value of b, and we end up with 0 plus or minus all this. And so really what you can see is b is essentially the only real part. If you are going to be having a complex root, it's just negative b divided by 2a is always going to be the real part of the solution. So that's an interesting observation we can get from this. So anyway, this is Keith from Kinvert. We did a quadratic equation with a complex root and the b value was 0. There is no, x, just first order x in this equation. We plug it into the quadratic formula anyway. We put 0 in the place of b and do everything else just as we normally would, and we come up with an answer here of x is plus or minus 5/2 I. So I hope this was helpful, and we will see you guys later. Bye.